So reading the problem, we have a 0.5 kilogram ball. Because of its unit kilograms here, we know we're dealing with mass. And in this problem, you realize we have two balls. So we're going to let this 0.5 kilogram ball be mass 1 then. All right. This ball is traveling 6.0 meters per second. Because of the unit meters per second, I know I'm dealing with velocity. So I know it's going to be v. Since this is the velocity of the first ball, the 0.5 kilogram ball, this is going to be velocity 1. And because this is the velocity before the collision, that means that this velocity will be my initial velocity then. So my initial velocity is going to be a positive 6.0 meters per second. Since I'm making this positive, that means that the other direction, the other sign of the other ball that's moving in the opposite direction should be negative. So if we continue on, it collides head on with a 1.0 kilogram ball. Since we have kilograms appearing again, we know that it's mass. And because it's the second object, this is going to be mass 2 then. It's moving in the opposite direction at 12 meters per second. So I know the velocity is going to be 12 meters per second. And because it's going the opposite direction, right? So it won't be positive, it's going to end up being a negative 12 meters per second. Now, it won't really matter if you make this 6 a negative, like negative 6.0 meters per second, and this 12 to be a positive 12 meters per second. It won't really matter as long as they have the opposite sign and you're consistent throughout the problem. But for our case, we're going to let this be positive, and we're going to let this 12 then continue to be negative. Continuing on, it says after colliding, so after the collision, the 0.5 kilogram ball, meaning mass 1, bounces backwards, okay, at 14 meters per second. And because of the unit meters per second, you know we're dealing with velocity. And this is talking about the 0.5 kilogram ball, so it's going to be the first velocity, and it goes backwards. So in our case, when it goes backwards, now it's going to be negative then. So this here, this velocity is the final velocity, and because it's going backwards, it's negative 14 meters per second. Find the other ball's speed and direction after collision. So we're finding the speed and direction. So in this case, it's asking us to find the velocity of the other ball, or velocity 2. And since it says after collision, this means that it's going to be the final velocity then. So our unknown is velocity 2 final. So now we have our equation that we need. I'll go ahead and substitute the values. Mass 1, we know it's 0.5. So we know we have a half. Times the initial velocity of the first ball, that's going to be a 6. Plus mass 2, which is just 1 kilogram, times the initial of the second velocity, which is negative 12, minus mass 1, which is 0.5, times final velocity of the first object, which is negative 14. Now it's all over mass 2. Mass 2 is, again, fortunately, it's 1. And so let's go ahead and simplify this. This term right here, 0.5 times 6, that gives me a plus 3. Plus 1 times negative 12, that gives me a minus 12. And negative 0.5 times negative 14, that gives me a plus 7 then. And since it's all over 1, I'm going to just keep it as this. That's equal to my V2 final. 3 minus 12, that's negative 9. Negative 9 plus 7, that gives me a negative 2 then. So we have negative 2 is equal to our final velocity. Remember the units for velocity? It's meters per second, so I'm going to put negative 2 meters per second then as my V2 final. Okay, so now we're going to double check our answer is correct or not. So we know that the final velocity of object 2 is negative 2 meters per second. Double check if our sign is correct or not. In some problems, it's a little bit tricky, so we can't really tell if the sign is correct or not, so we're going to just move on. And then next check, is your value too small, too big? It's not 0.01 meters per second, and it's not 1 million meters per second. So our value kind of seems right. So we'll go ahead and stick with our answer then.